Welcome everyone to a new lesson in remote sensing techniques, or more or less using ArcGIS for this purpose. Today I would like to show you some small introduction into ArcGIS, how to use it, how to import raster data, and also how to manipulate raster data in ArcGIS. And we will concentrate therefore on the ArcGIS version 10, especially on the Service Pack 1 edition, due to the fact that the first build of ArcGIS 10 has a lot of failures in it, especially in the projections. Therefore we will start ArcGIS. There we go, and it's more or less ArcMap and the version number 10. And as you can see, I have a very customized view on it, so I would like to explain you some details. First of all, you will be presented with this getting started dialog, and therefore you will more or less see no recent projects. In my case I have 4 of them, so we will use a new template, something called a blank map. And don't forget there's a second dialog on the screen, especially on the lowercase here, the default geodatabase for this map. What does it mean? So if you're doing some kind of calculations for your raster or some kind of savings, it can be stored in this default geodatabase. So you can adjust it like here. So I'm not very pleased with that. Some find it very easy to understand. I'm more or less this old-fashioned guy who has a special folder, something called a work directory or something like that, and I would like to store my data in it. But if you have a lot of data, and especially if you would like to use it in ArcGIS Server or any other ArcGIS application, you should get to know these kind of geodatabase. So we will start with a blank map. Just press OK, and so there's a lot of things you can see in this screen here. So let me just arrange some things. You will probably see this blank view over here. This is a so-called data view. You can see it in this small scaled button here, and then you have a section called table of contents, where you can where you will have an overlook over your layers which you have imported in your data. And there's also something called Arc Toolbox. These are the tools you can use on your data sets like raster data, geodatabases, tables, shapefiles, whatever. And you can also adjust the dialog over here. So this is the Arc Toolbox window, which will open. Just press it and you will have your tools available for the moment. If you have a complete version of it, containing also the Arc catalog, which is very expensive, you can also get access to that on this right case. And as you can see, it is opening automatically, so I'm not pressing any button here. And you can adjust the visibility by just press auto hide here, and so it won't disappear anymore. So yeah, we will just close it for the moment, and we will concentrate on the data view, and especially in that, getting your data into the view. So what we are having here are a lot of tools available. I will go into detail in some moments or some minutes or maybe some sessions. What is the most important in that is that you can see here something called add data, and we will start with adding data, and after that I will go into some details like the layers and the projections and everything like that. So please mark beforehand that on the lowercase here you can see that there's no projection available, so there's no metrics in it in your data view, so you don't know whether these are meters, miles, or whatever, because there's no data available. So we will add some data in a moment. I've downloaded some ETM plus data from landcover.org, and also a topographic data set called SRTM, and we will start by adding maybe this layer. So this is a TIFF file. you can just select datasets and layers, and he will find all available data in your folder. So we will use that, and just press add, and that's it. Something you have to know beforehand is that you can, if you're selecting some data, you have these folder connections. Normally, you can just select data from your personal geodatabase, which I have explained in the first moments. So you have to make a folder connection to that. So therefore, just go to the folder connections, and you can adjust or create a new folder connection by using this button, connect to folder. This is probably some kind of disturbing in the moment, so just make sure that you have some kind of working directory or special directory where you are storing, or where you will store all your results, raster data, and all your geo data. So just make folder connections like that, choose your folder, press OK, everything is fine. So I've done this beforehand, so I have now the folder connection to my desktop, and in this folder connection I have the ArcGIS tutorial folder. So I'm using that one. Now I can choose my layer and press OK. And what you can see now at the moment is that you are having some more information in your data view. So you have a metric now, and you know something about the projection. It's not much, but you know that you're measuring in meters here. So we will go into our in our layer, just make the right button, click the right button, and use properties. For ArcGIS, it's very important to know that the right button will be your friend in that program. This is such a deep structured program. You can get into I think something like the 10th layer of your dialogues here, something like that. So please make sure you're using the right button if you're not aware, or if you don't know what to do. There's some kind of disturbing, but you will see it, especially in a video I've made called Making Maps with ArcMap or with ArcGIS. You can see some of that right-clicking adventures over there. So we are now having the layer properties in this case. So you see some kind of tabs here. So we have the general, what is the layer name. This will be important by making maps afterwards. You can select the scale range, how far you can zoom in and zoom out on this data view, and it depends whether you would like to see this layer in a certain scale. So if you're far away from the layer, shall it still be shown on the data view, or shall it not? So you have a source, and this is the most important in it at all. So you have some kind of properties like the number of columns and rows, the number of bands, the cell size, which is approximately 30 meters in that case. You will also have something like the extent, and which is the importance, or the most important at all, is 55. This is not the case. So if you're dividing this possible scale or color scheme here into upper and the lower part, the part between 0 and 255 is more or less gray. So this layer has a lot of gray in it. And oh no, that was a wrong case. So going back, so you have some kind of undo, add layers, and redo functions in it here as well. I will concentrate more on the view now. So you also have a fixed zoom in. As you can see here, there are some scales automatically chosen, and you can use that one. And there's also go back to the previous extent. So if you're doing some kind of strange things like that, just seeing here 1 pixel, you can go into you can go back to the prior state of your view. And then you have a select elements button. This is not useful just by using raster data, and which is quite important is the identify buttons. So if you're not sure what is a value you can see here, you can also have a look, more or less, or mostly the case, into the MET file. in this MET file, this is MET file for this special scene. So you have Landsat surface reflectance, and it is provided by the global land cover facility, and so there you have a processing date, a product version, and as you can see, normally the Landsat data is presented in radiation. So you have a value of 0, which means no radiation, or more or less it is a bounding box of the scene. Then you have 1, which is no radiation, and you have the value of 255, which presents full radiation according to the sensor. So if you're looking into that MET file in this, you can see that you are having here some kind of attribute. So the dimension in the Y, the dimension in the X, and then you have here an attribute at back. Some of you don't really know what contrast means. I will show you later. Then you have a brightness value and a transparency value, which is quite useful if you're using more than just one layer. So we will go with the 0 at the moment, and you can see the here. So let's go back to properties, and you have a symbology. Symbology is very useful by choosing a good color representation of your values. So for this case, grayish values are the best I think you can use, because the band number 7, it is just one band. I will show you later on how to calculate or how to create a raster data set, which will show you the data in real colors. And as for the moment, use the grayish ones, especially by let us assume that you have some kind of topography layer, or we will just remove that layer. And as you can see, I have a topography layer which is called SRTM. I will just add that at the moment. So the projection system is, we could check that. Properties, just go on the source and check the so you have a representation of height, which is more or less common, and I don't think that this color scheme is so common. You can also adjust the color scheme by clicking on the color table here, and then you have this little dialog over here. So quite useful color schemes are especially this color scheme, which goes from this very azure, I don't know the English term for that, up to white. I most like this color scheme over here. We will use this, and as you can see now, the lowest parts are represented in brown, which is unuseful or not common. So I will invert the color scheme, and now my higher values are represented in brown and my lower values are represented in this blue. But let's be honest, you cannot see anything. So we will concentrate on the problem of contrast now. So let's go back into the properties of this topographic or this height data. Go to properties, and you can see here in the symbology tab that you have some kind of labeling, so you can label your data, and choosing this slider will show you at first hand a background value. So the background value in the 16-bit system is it depends on your data. So normally, or in most cases, it will be the lowest possible value in your data, but as you maybe have small contrast, and this is your input data. So this is the raster data, and you have an output section over here. I've just changed this axis here. So you have an output section, which is a representation of on your screen maybe. So if you're just making no attachment or no arrangement of the contrast, the input data will be just converted to your output or to your screen contrast like this. So you have a line over here which will connect the 0 and the 255, so the maximum value of your possible bit system. So it depends on the bit system also. So in this case we have an 8-bit system. In the 16-bit system the maximum possible values was 32,000 something and the lowest possible minus 32,000 something. And by using contrast, it means that you're connecting your something like your curve with this with this magic line over here, and just arranging or mirroring your curve to your output screen. So you still have a small contrast. So how can you increase your contrast in the scene? This works by changing this line. So we will go along and create a new mirroring line, maybe like this. So you have this area here and then a bigger slope of that line. And if you're using the same system, so just connecting this point of the curve with a line and reprojecting it, you will get something like this. So we have this point here reconnecting, same length overall, same length, and in the last case this one connected to this point. If you have some books or something like that. So we have greenish colors for the lower areas and brownish colors for the higher areas. But what is the problem now in this case? As you can see, there's no differentiation in this whole area. So there are a lot of different heights. As you can see here, we have a height of 1,414. There's 1,378, and so on. But it is all represented by the same height. There's one. I will show you maybe that, not at the moment. So we would like to get a full scaled color scheme in your area. So what we will do now, we'll just remove that layer and use our toolbox. So press our toolbox, and there you have or you should have a tool called Data Management Tools. Just expand it. The height representation in your data. What I would like to show you now is some kind of application like creating raster sets, especially when you're downloading Landsat data, and most of you guys maybe want to use that as a first step into raster processing in geoinformatics. We will go into that, and I would like to show you how to use it. So you more or less will begin with something like first band, second band, and so on. So we will adjust this, or I would like to show you these three ones. We'll just click add, and what you will now see is just gray. So there are three different layers in the scene. In the end, we will adjust the visibility of the scenes, and in the end we will calculate real colored satellite scene or something like that. So you now have the first band in the upper part, second band and third band, and as I have said, you can adjust the colors, you can adjust the visibility of the bands. We'll add maybe now the SATM scene. We will adjust the area. So now the SATM scene is beneath all the other layers, and just by making the other layers invisible, you can see your area now. And just go with the identify button as I've shown you. So the all layers is used in the moment, so you can use this this for getting an information about your scene. You can use the topmost layer. There's just only the SATM scene, so topmost layer is the topmost visible layer in the moment. Visible layers as well. Selectable layers, there are no selectable layers. Selectable layers are shape files or something like that. We will go with all layers in a moment. So you can see here that there's a height of about 2,000 meters above sea level, and it is represented by the value of 237 in the ETM Plus scene. So for the purpose of creation of a real scene or something like that, a real satellite image which is represented in real colors, we will use something called a layer stack or composite of these three layers. So the band number 1 is representing the blue color, the band number 2 is representing the concentration of green, and the third band is representing a concentration or reflection of red color. So we will use the toolbox, once again use the toolbox, and I've prepared it, sorry for that. So go back to the data management tools, the raster. We have seen them here for the raster properties, the calculation of the raster statistics, and now we will use the raster processing toolbox. And there's this a function called composite bands. So what will it do? So it will make a stack or something like it will add these three layers to one scene. So go into detail, create composite bands, and as you can see here you have input rasters. So it creates a single raster dataset from multiple bands and can also create a raster dataset using only a subset of bands. So we'll use now our band number 1 has a first band, the band number 2 has a second, and the band number 3 as the third. And then you have an output raster, and we will adjust this output raster location. So as you can see, we have not adjusted our default geodatabase. So every time you will be conflicted with that default geodatabase. So we'll go into this is the ArcGIS tutorial folder, and we will create a layer stack. Please choose good names for that, so it's ETM Plus, and the layers used are 1, 2, and 3, and this will be stored as a TIFF image as all the other layers. So it's now TIFF layer stack. Everything seems fine. We will just press OK, and it depends on your system. So normally it will probably show up in your layer section afterwards. I've arranged it that all the results of my toolbox actions will not be presented in the layer sections automatically. I have to add the data afterwards in a single process. So we will just wait here. Now 40% is ready, 63. It takes some time. Now we are ready, and we will just use the add data. There's our layer stack ETM Plus 1, 2, 3. By just clicking on the red color and say the red color is represented by band number 3. The green color is represented by band number 2. That is fine, but the blue color is represented by band number 1. And yeah, we are in central Mongolia, so there's a lot of steppe vegetation, and this is not very dense vegetated. So there should be, or it should be visible, a lot of soil, which is represented normally as some kind of brownish colors. And here we have it. So there is the steppe, brownish colors. We are in the end of the growing season. So the scene was taken in August 2001. You have the floodplain, which is accompanied by greenish colors due to the dense vegetation in the floodplain, by grass and something like that. So you have the city of Rahorin here. You can easily see, and you have the tiny river going through the valley, and this is also represented by darkish colors, and not really by blue, but we will go to the lake in the upper part of the scene.